Episode 70, titled Web Attack Surface, Inputs, Auth, Sessions. We're focusing on how web apps break through three recurring seams: inputs, identity, and sessions. Web application compromise rarely looks like one dramatic bug. It's usually a mismatch between what the app assumes and what the attacker can control, especially around data entry points, authentication flows, and the trust that persists after login. When any of those areas is weak, attackers can often bypass controls without needing sophisticated exploits, simply by sending well-chosen requests and observing the results. The goal of this episode is to build a practical map of where web risk lives so you can prioritize validation safely and report findings clearly. If you can think in these three seams, your testing becomes more structured, and you stop missing important access control issues while chasing only injection.
Inputs are any user-controlled data the application consumes, and that includes far more than just form fields. Forms are obvious because users type into them, but headers can also be user-controlled through clients and proxies, and they can influence behavior like content handling, caching, and authentication. Parameters in URLs, query strings, and request bodies are also inputs, and they often drive object selection, filtering, and business logic decisions. Cookies can be inputs too, especially when the application stores state or preferences in the client and trusts them too much. File uploads are a special kind of input because they include both content and metadata, creating multiple places where validation can fail. The key is that input means anything the server receives that the client can influence, whether the UI shows it or not. When you learn to see inputs this way, you stop testing only what is visible on the page and start testing what the application actually processes. Authentication surfaces are where identity is established, and web applications often have more of them than teams realize. Login is the obvious entry point, but multi-factor flows introduce additional steps, state, and failure modes that can be abused through prompt fatigue, bypass logic, or inconsistent enforcement. Password reset workflows are another major surface because they often involve email links, codes, security questions, and help desk processes that can be weaker than the main login. Single sign-on entry points add their own complexity because they rely on trust relationships, redirects, and claim mappings that can grant unexpected access if validation is weak. Account creation, device enrollment, and recovery settings also become authentication-adjacent surfaces because they influence who can authenticate and how. The web mindset is to treat authentication as a set of flows, not a single form, because attackers look for the easiest entry point, not the most obvious one. In assessments, mapping these surfaces early gives you leverage because identity failures often unlock everything else. Sessions are the mechanism of continuing trust, and in web apps, that trust is commonly represented by cookies and tokens that control access on subsequent requests. After the application decides you are authenticated, it issues a session identifier, or token, so you can keep interacting without re-authenticating every time. That convenience is also a risk, because if an attacker obtains the session artifact, they may not need the password or the MFA step at all. Session security depends on how the artifact is stored, how it is transmitted, how long it lives, and how reliably it is revoked when a user logs out or changes credentials. Weak session handling can also show up as fixation, where the app allows a user to authenticate into a session the attacker already knows, or as overly long lifetimes that make replay practical. Because sessions are post-login credentials, they should be treated with the same seriousness as passwords, even though they look like harmless strings. On the exam and in practice, session issues often explain why MFA is enabled does not prevent access in a compromised scenario. Authorization boundaries are where many web apps fail quietly because they are harder to test than simple input validation, and they often require thinking in roles and objects. Roles are the user categories the app recognizes, such as standard users, managers, and administrators, and role checks determine whether functions should be available. Objects are the data entities the app stores, such as records, files, invoices, or user profiles, and object-level authorization determines whether a user can access a specific instance of that entity. Function-level permissions control whether the user can execute an action at all, such as exporting data, changing settings, or viewing admin pages. Authorization failures often occur when developers assume the UI will prevent access, forgetting that attackers can call endpoints directly. They also occur when object identifiers are trusted without verifying ownership, enabling one user to access another user's data by changing an identifier. When you test authorization, you're not testing whether the app has a login. You're testing whether it enforces boundaries after login consistently.
Common weak points concentrate around features that handle complex inputs, sensitive actions, or bulk data movement.
File uploads are high risk because they combine content processing with storage, and they often involve validation gaps or insecure handling. Search endpoints are high risk because they accept user input that may influence queries, filtering, and back-end performance, and they can reveal information through error behavior or side-channel responses.
Exports and reports are high risk because they often provide bulk access, which magnifies the impact of authorization mistakes.
Admin pages are high risk because they concentrate privileged functionality, and they sometimes expose features unintentionally through predictable paths or misconfigured access control checks.
Bulk actions, integrations, and API endpoints can be equally important, especially when they are less visible in the UI, but heavily used by clients and automation.
The practical lesson is that the most useful features are often the most dangerous when boundaries are weak.
When you map an application, you give these features extra attention because they offer high leverage for both attackers and defenders.
Mapping flows is a discipline that turns web testing from random poking into a structured assessment. You start by identifying what is public, meaning what can be accessed without authentication, because public surfaces are the most reachable and often the first foothold. Then you identify what requires roles, meaning which functions and endpoints differ by user type, because role boundaries often contain the most important authorization logic. You also identify where sessions are created, renewed, and revoked, because session boundaries determine how long trust persists and how replay might work. You trace how the application moves from one state to another, such as from anonymous browsing to authenticated access to privileged functions, and you note where the app relies on redirects, callbacks, or client-side state. This flow mapping is not an exhaustive diagram. It is a mental model of what changes trust and what changes capability. Once you have it, your test choices become clearer because you can target boundary transitions rather than isolated pages.
Now, consider a scenario where you find a hidden endpoint, because this is a realistic way web attack surface expands beyond what the UI shows. Imagine you discover an endpoint that is not linked anywhere in the interface, but is accessible through a predictable path or an observed request pattern, and it appears to accept parameters that influence data retrieval. The clue is that the endpoint exists outside the normal navigation and may not have received the same access control and input validation attention as the main flows. Likely input risks include the endpoint accepting user-controlled parameters that select objects, filter results, or trigger back-end processing, which can create both injection-style risks and access control risks, depending on how the server enforces checks. A hidden endpoint can also expose debug behavior or verbose errors that reveal internal details and make other attacks easier.
The safest immediate step is to map how the endpoint behaves for different authentication states and roles, and to observe how parameter changes affect responses.
You are looking for patterns like the UI hides it but the server accepts it, which is a common source of real-world web issues.
A major pitfall in web testing is focusing only on injection and missing access control problems, because injection is familiar while authorization failures can be subtle.
If you only test for classic input exploitation, you might miss that the app lets a standard user access admin endpoints or lets one user read another user's records by changing an identifier.
Another pitfall is assuming that a visible permission boundary in the UI implies server-side enforcement, which is a dangerous assumption because attackers do not use the UI.
There is also a pitfall in overusing heavy payloads early, which can destabilize services, trigger defenses, or create noisy logs without first confirming whether a boundary problem exists.
The disciplined approach is to test the simplest boundary questions first, such as whether roles change responses and whether object identifiers are enforced.
Those tests often produce high-impact findings quickly with minimal risk.
On the exam, the correct answer is frequently the one that checks authorization and session behavior before attempting deeper input exploitation.
Quick wins come from testing role differences and object access with simple requests, because those checks are low effort and high signal. Role testing means comparing how the same endpoint responds under different user roles, looking for unexpected access to privileged functions or differences that are not enforced consistently. Object access testing means selecting an object identifier you should not be able to access and seeing whether the server enforces ownership or scope checks, using minimal requests and minimal data exposure. These tests do not require complex payloads, and they often reveal the highest impact issues because they directly affect confidentiality and privilege boundaries. They also map cleanly to remediation because defenders can fix authorization checks and role mappings more directly than they can fix everything about input. A simple request that proves an access boundary failure is often more valuable than a complex injection attempt that requires perfect conditions. That is why these quick wins should be in your default web playbook. Safe validation thinking in web work means confirming behavior changes without destructive payloads, especially when you are dealing with production systems or sensitive data. You aim to demonstrate that the application behaves incorrectly under controlled conditions, such as returning a success where a denial is expected, or granting access to a function that should be restricted. You avoid actions that modify data, trigger bulk exports, or scrape large data sets, because those increase harm without increasing proof quality. You choose minimal examples and stop when you have a clear demonstration of the boundary failure, documenting the request and response pattern in a way that defenders can reproduce. You also pay attention to session safety, such as avoiding actions that could invalidate other users' sessions or cause state confusion. The professional standard is to prove the issue while minimizing the risk that your validation becomes an incident. When you validate safely, stakeholders trust your findings and act on them faster. Reporting language should describe the affected function, impact, and recommended control clearly, because web findings need to translate into engineering work. You identify the function, such as a specific endpoint or workflow step, and you describe the condition observed, such as missing authorization enforcement or improper session invalidation. You explain impact in terms of what an attacker could do, such as access other users' data, perform privileged actions, or reuse sessions without reauthentication, without exaggerating beyond the evidence. You recommend controls that address the root issue, such as enforcing server-side authorization checks, tightening role mappings, adding step-up requirements for sensitive actions, and improving session lifetime and revocation behavior. Clear reporting also notes constraints, such as limited testing due to production sensitivity, and it emphasizes that the evidence was obtained through minimal, non-destructive validation. This style makes the report both credible and actionable. To keep the web surface model clear, use this memory phrase: input, identity, session, authorization, function. Input reminds you that every user-controlled value is a potential influence on behavior and must be validated and constrained. Identity reminds you that authentication flows are multiple and often have weak edges, such as reset and SSO entry points. Session reminds you that continuing trust is represented by cookies and tokens that can be stolen and replayed if mishandled. Authorization reminds you to focus on roles, objects, and function-level checks because those are common failure points that bypass UI controls. Function reminds you to map risk to specific features like uploads, exports, search, and admin pages because those functions concentrate impact. When you repeat this phrase, you are less likely to tunnel vision on one class of bug and miss the broader access story.
To conclude episode 70, titled Web Attack Surface, Inputs, Auth, Sessions, remember that web compromise often happens where inputs meet identity and sessions, and where authorization boundaries are assumed rather than enforced. A structured approach maps what is public, what requires roles, and how sessions persist, then tests the simplest boundary questions before escalating to heavier techniques. Your checklist is not a list of payloads, it is a model of trust transitions and control points across the application. Now, mentally map one web feature end-to-end as practice. Pick an export function, identify its inputs and parameters, identify the authentication and role required to reach it, identify the session artifact that authorizes the request, and identify the authorization checks that should constrain which records can be exported. If you can walk that feature from input to identity to session to authorization, you will find weak points faster and validate them more safely, which is exactly the skill this episode is meant to build.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.